The asteroid Pallas, its extreme orbital inclination, and its heavily cratered cosmic golf ball appearance resulting from violent collisions. It is primarily composed of numerous rocky remnants. Between Mars and Jupiter lies the asteroid belt, a vast orbiting junkyard of solar system remnants. Most of its objects drift quietly, on a flat plane, but one giant among them carves a path of reckless chaos, suffering a relentless, violent fate. We travel to Pallas, the third largest object in the belt. Pallas is a notable example with its significantly tilted orbit compared to the main belt. Pallas is a protoplanet with a diameter of roughly 300 miles. Its orbit is inclined at a significant 34-degree angle relative to the main asteroid belt. This steep inclination distinguishes Pallas from most other asteroids. The high inclination causes Pallas to intersect the orbits of other asteroids at high speeds. Pallas, an asteroid, has a unique orbit that is inclined relative to other asteroids. This inclined orbit leads to a higher frequency of collisions with other space objects. Collisions involving Pallas are approximately 4 times more energetic than those of Ceres and Vesta. The higher energy is due to the increased relative speeds at the point of intersection. These high-speed impacts result in more forceful and frequent collisions for Pallas. The energetic collisions experienced by Pallas contribute to its surface features and orbital evolution. Pallas's surface is characterized by a high density of impact craters. These craters vary significantly in size, ranging from small to large. This extensive cratering gives Pallas the appearance of a heavily scarred surface. The high crater density is a result of numerous collisions throughout Pallas's history. These collisions have shaped and marked the asteroid's surface over billions of years. The surface provides a visual record of the asteroid's exposure to space debris. The unusual orbit of Pallas presents an unsolved mystery in astrophysics. One theory suggests a massive glancing blow from a now-vanished planet altered Pallas's trajectory. This impact could have imparted the high inclination and eccentricity observed today. Another hypothesis involves gravitational disturbances from Jupiter during the solar system's early stages. These disturbances might have perturbed Pallas's orbit, leading to its current atypical path. Next time, we seek out a cosmic anomaly. Join us for episode 11, The Ghost Galaxy.